this problem, we're asked to find the area of this peculiar shape. So I'm going to have to recall a couple formulas here. The area for a rectangle in general is length times width, and the area of a circle in general is pi r squared. So I'm going to use those two facts to figure out the area of the shape that's pictured. So in blue, let me draw in a rectangle that I can almost see. See a rectangle that goes from here to here to here to here. And so the area of the rectangle that I've drawn in would be, in blue, 16 times 25. Notice it's 16 inches times 25 inches, so we'd be talking about 16 times 25 many square inches when I get my units together. Now unfortunately, that area would overlap. We actually only want the area that's located in here. We don't want this area down at the bottom. So I have to look at this and realize that I don't have a complete rectangle. I have a rectangle, but it's being subtracted by a half of a circle. This semicircle is being cut out of that piece of paper that would have been a rectangle. So that means I'm going to have to subtract the area of half of a circle. So I'm going to take that 16 times 25 and I'm going to subtract a pi. I need to figure out what r is, so notice that since the top is 16, that means my diameter down here is also 16, and therefore my radius would be 8. So we have a pi times an r, which is 8 squared. That would be one whole circle, but we don't want the whole circle, we want half of a circle. So I need to do 16 inches times 25 inches minus pi 8 inches squared over 2. So I'm going to grab a calculator here, see what I end up getting. 16 times 25 subtracted by, we'll use 3.14 for pi, times 8 squared divided by 2, and if you followed along on your own calculator, you should have gotten an answer of 299.52, and these would be inches squared for this particular object. Okay, so why don't you pause the video or review it, look at it again, and see if you can try this problem on your own. This problem looks like it has a rectangle that is bordered on each side by a half of a circle. So we're going to use the same formula. So assuming you paused the video here and tried it on your own, this time it doesn't look like a rectangle minus a half a circle. This time it looks like we have a rectangle, right, located right here, and then it's going to be added to two halves of a circle. So in this case our area would be, well, let's see, the outside, the first area, the rectangle area, would be 90 feet multiplied by 62 feet. So we're getting foot squared as our units. And last time we subtracted an area because we had a circle that was being cut out of a piece of paper, but this time it looks like we're adding on additional area, adding on two additional areas in fact. So this time we're going to be plussing. Also, since the diameter is 62, looks like the radius would have to be half of that, which would be 31. So here we're going to take pi times the radius, which is 31 squared, pi r squared for the area of a circle. We're going to cut that in half because we're looking at semicircles. But then I'm actually going to take that result and multiply it by 2 because there are two semicircles, one on the left and one on the right. So hopefully you got something similar, and if we put this into our calculator, we'll end up getting 90 times 62 plus 3.14 times 31 squared divided by 2 for the semicircle, but then multiplied by 2 because there are two of them, and it looks like we got a big answer this time. Hopefully you got a big answer of 8,597.54 foot squareds. Hopefully you got the same answer I did.